Hey guys, it's me Shan. So today I'll do a video about atomic structure part 1. So yesterday, day before yesterday, I made a video about the final basic concepts of chemistry. So guys, I did post a video yesterday like the same thing, but since I don't have enough storage, I had to retake the video again. So let's try real quick. So atom. So yeah, first look at the title, atomic structure. So if you want to know more about atomic structure, first you want to know what an atom is. So atom. John Dalton proposed in 1808 that atom is the smallest indivisible particle of matter. We already know that, in which atom radii are the order of 10 power minus 8 centimeter. It contains 3 subatomic particles, namely protons, electrons, and neutrons. So in atom there are like 3 parts: protons, neutrons, electrons. So now let's look at electrons. So electron was discovered as a result of study by cathode rays by J.J. Thomson. It was named by a prolific scientist known as Tony. He carries a unit negative charge minus 1.6 to 10 to the power of minus 19 C. Mass of one electron is 9.11 into 10 power minus 31 kg, and mass of one mole electron is 0.55 milligram electron. Now let's look at protons. Lord Ernest Rutherford discovered proton on the basis of Anno ray experiment, in which it carries a unit positive charge plus 1.6 into 10 power minus 19 C. The mass of proton is 1.007276 U. Next thing is neutrons. So neutrons are unusual particles. Was discovered by Sir Chadwick in 1932. The mass of neutron is 1.675 to 10 power minus 24 grams, or 1.008665 AMU or U. So I'll take a look. You take a look at this answer. Okay guys, so I'm back. So you can pause it if you want. So I'm gonna just try to make the video kind of quick because I don't have a lot of storage, guys. I really have to do this. So the next thing, some uncommon subatomic particles are positron. Positron, we know that electrons are normally negative, but this is a positive electron. Positive electron discovered by Dirac in 1930 and Anderson in 1932. The next thing is neutrino and antineutrino. So neutrino and antineutrino are particles of small mass and no charge, are known as neutrino and antineutrino, as stated by Fermi in 1934. Next thing is meson. Meson discovered by Yukawa in 1935 and Kemmer. They are unstable particles. Antiproton, the next thing, is a negative proton produced by Sager and Weyden, two prolific German scientists in 1955. The next thing is different types of atomic species or elements. You can also call them a species or elements. So first thing is isotopes. Species with same atomic number but different mass number are known as isotopes. Second is isobars. Elements with same mass number but different atomic number are known as isobars. Isotones. Elements with same number of neutrons are known as isotones. Next three you might have not heard, or you could have heard about it. The next thing is known as isodiaphers. Elements with same isotopic number are known as isodiaphers. And isoelectronic. Elements with same number of electrons are known as isoelectronics. And isosters. Elements having same number of atoms and same number of electrons are called isosters. Let's look at the example for isotopes. Isotopes is 1H1 and 1H2. For isobars it's 18 AR40 and 19K40. Third one, isotones, 1H3 and 2He4. Fourth one, isodiaphers, is 19K39 and 9F19. And the isoelectronic one is Na plus and Mg plus 2. And the last one is isosters, example N2 and Cu. So take a look, guys. Because the last thing is known as Heisenberg's uncertainty principle. You might have learned about Heisenberg in 8th standard or 9th standard. I don't think so, because he was like the one of the scientists who gave us quantum numbers. I'll teach you guys next video because there's like a lot of this concept how to go through. So Heisenberg uncertainty principle. According to this principle, it is impossible to specify at any given instant both the momentum and the position of subatomic particles like electron. So the theory goes as follows. Delta x dot delta p is greater or lesser than h by 4 pi, where delta x is equal to uncertainty position. So in an atom, the electron revolves around the orbit. So Heisenberg what clearly says that we do not know where the electron revolves around. It can be like up, it can go. We just cannot define. Like imagine, yeah, this board. So this board, it doesn't move. If it moves, we cannot specify. Like we cannot like literally prove that it stays there, it goes there, because no one would know except you. If you have saw the whiteboard move, then you would have known the whiteboard has moved. But electron is not that. So imagine this. Imagine this as an electron, and it is revolving around an orbit. You can see with an electron microscope, but you don't know which position it is. It can go at a very high altitude, low altitude. You might just not know. The second thing is delta P is known as uncertain position. Same as uncertain momentum. The first thing, same, it revolves, but we don't know what speed it goes. That's the same thing that Heisenberg uncertainty principle derives. So I hope you guys have understood everything from the video. So tomorrow I'll also try to do atomic structure part 2. So see you guys tomorrow. Bye, this is Misha. I'm signing off, guys.